Welcome to our tutorial on optimizing MLServer for real-time performance, where you'll learn essential skills to configure and tweak MLServer for maximum throughput and minimal latency. Imagine if your favorite streaming service took minutes to load each video. Frustrating, right? In our fast-paced digital world, the speed and accuracy of machine learning servers are crucial. Today, we'll explore how to optimize MLServer for lightning-fast real-time performance. We'll dive into the architecture of MLServer, understand why speed and accuracy are vital, and cover practical techniques to enhance your server's efficiency. By the end of this video, you'll be equipped with the knowledge to maximize throughput and minimize latency, ensuring a seamless user experience. To optimize anything, you must first understand it. MLServer is no different. At its core, MLServer consists of several key components: inference engines, data processors, and connectors that integrate with your existing systems. Each plays a critical role in how data is processed and decisions are made in real time. The architecture is designed to facilitate seamless data flow and efficient processing. By understanding these building blocks, we can begin to identify bottlenecks and areas for improvement, ensuring that our MLServer deployment is primed for optimal performance. Once you understand the architecture, it's time to roll up your sleeves and dive into configuration. Adjusting server settings can drastically improve performance. Start by optimizing resource allocation. Ensure your server's CPU, memory, and GPU resources are adequately allocated to handle real-time demands. Fine-tune performance settings to leverage your hardware's full capabilities. Remember, what works for one use case may not work for another, so tailor your configurations to your specific needs. With careful adjustments, you can unlock the full potential of your MLServer setup. Caching is a powerful tool in the optimization toolkit. By storing frequently accessed data in memory, caching reduces the need for redundant computations, significantly boosting response times. MLServer supports various caching strategies, from in-memory caches for speed to disk-based caches for persistence, and hybrid approaches that combine the two. Implementing an effective caching strategy can drastically reduce latency, ensuring that your server can handle high demand with ease. By understanding and utilizing caching mechanisms, you'll be one step closer to achieving real-time performance.
In any high-demand environment, load balancing is crucial. Efficiently distributing traffic across multiple MLServer instances prevents overloads and ensures consistent performance. Utilize load balancers to evenly distribute requests and scale your servers dynamically during peak times. By implementing smart load balancing strategies, you can prevent bottlenecks and maintain high throughput. Remember, an overloaded server is a slow server, so balance your load to keep things running smoothly and efficiently. Effective optimization doesn't stop once your server is up and running. Continuous monitoring of performance metrics is essential. Key metrics to track include latency, throughput, and error rates. Utilize tools like Prometheus or Grafana for real-time analytics and insights. By keeping a close eye on these metrics, you can quickly identify and address bottlenecks, ensuring your MLServer deployment remains optimized. Use this data to guide further optimizations, making adjustments as necessary based on current performance trends.
As demand for your services grows, so too should your server capacity. Scaling MLServer instances ensures high availability and performance. Decide between horizontal scaling, adding more servers, and vertical scaling, upgrading existing servers. Each approach has its pros and cons, and your choice will depend on your specific needs and infrastructure. Consider dynamic scaling strategies to automatically adjust resources based on demand. Whether you're using cloud services or on-premise solutions, ensure that your scaling strategy aligns with your performance and budgetary goals.
Latency is the enemy of real-time performance. In high-demand scenarios, even milliseconds matter. Start by identifying sources of latency within your data pipeline. Techniques such as optimizing data flows and leveraging edge computing can significantly reduce delays. It's a delicate balance between speed and accuracy, but with the right strategies, you can achieve both. By consistently working to minimize latency, you'll ensure that your MLServer deployment meets the demands of real-time applications. Optimizing MLServer isn't just about technical tweaks, it's also about strategic planning and execution. Start by developing a comprehensive deployment strategy that considers security, compliance, and scalability. Testing and validation are crucial to ensure that your optimizations work as intended. Don't forget about documentation and support. Having clear guidelines and resources helps maintain and improve your deployment over time. Finally, adopt a mindset of continuous improvement, always looking for new ways to enhance performance and efficiency.
We've covered a lot of ground today, from understanding MLServer architecture to mastering deployment strategies. Remember, the key to real-time performance is continuous optimization and monitoring. Now it's your turn to put these strategies into practice. Join our community discussion to share your experiences and learn from others. And don't forget to comment below with topics you'd like us to cover next. Together, let's continue to push the boundaries of what's possible with MLServer.